A little bit earlier today, we sat here and chatted with John Monett from Sonex Aircraft about their entry into the unmanned market. And my next guest is Richard Leverich, and he's with NASC. And Richard, I understand that you're the company that's taking the Sonex aircraft,
correct,
basically turning them into UAVs.
That is correct.
Tell us about that process.
Well, we needed an aircraft that could do a very specialized job. It had to be very strong, very maneuverable, low cost, and be able to be transitioned into a UAV. We looked at a lot of aircraft, build one of ourselves, but that didn't work out the way we wanted to, and comb the market until we come upon John Monett's Sonex Aerospace, and we found an airplane that fit our bill, and we've built it. As you can see, it's on the other booth over there, and it turned into quite the aircraft. So our relationship with Sonex has been incredibly successful.
What was the challenge of taking what is essentially a manned airplane, and a kit airplane at that, and turning that into an unmanned aircraft?
Not as much as you might think.
Okay.
We removed a lot of the manned systems, and that gave us an incredible amount of space to work with. So the challenges aren't as much as you would think. I would say the biggest challenge is defining what we wanted to do once we found all that space. The conversion went extremely well, and one of the reasons for that is we used all of the command and control from our previous aircraft, that being the Tiger Shark. Okay, so it was we didn't have to invent all that much. We just had to adapt.
When you say you took out the manned systems, what did that entail?
The seat,
Okay.
all the controls in the control panel, the stick, the pulleys, the cables, and all the rest of it. We needed none of that. Rudder pedals, seat belts, they all weigh, and what that adds is payload to the aircraft. So we would claim all of that weight, and that worked out very nicely.
So you're running everything then on servos?
Yes, we are. Entirely, it's a completely autonomous aircraft. You can program it to take off, go do its mission, and come back and land all by itself.
And I guess the other question that comes to mind is, that changes the weight and balance calculation on the airplane.
Very much. As it turns out, it changed it in our favor as far as the balance is concerned, and we could leverage that change, if you will, into payload space and be able to put a lot of weight where it needed to be, where the man used to sit. In our case, it was a tremendously large fuel tank. So the airplane has a long range, and it worked out nicely that we replaced the man with fuel.
So what is the mission for a Sonex-based UAV?
This particular Sonex-based UAV, there are other models, but this particular one, and this is the Tradeshow, it's high altitude research and development, communications platform, over the water, over the ocean, if you will, maritime patrol or anti-submarine warfare, a number of missions of that nature. A lot, though, our first is probably going to be research and development with one research university or the other.
You also mentioned the purpose-built UAV that you had, the Tiger Shark.
Yes.
Tell us about that aircraft and how it differs from the Sonex.
Well, it's a completely different airplane for completely different use. The basic Tiger Shark is a military-based, it's a RQ-23 Alpha. We have stopped manufacturing that, and we have the Tiger Shark XP, which is the exportable product, and that's what's here on the floor today. And that is much smaller aircraft. It's precisely 1/3 the size. So it's a 500-pound gross weight, whereas the Tradeshow is 1,500 pounds. So they're completely different missions. One's a Group 3, the other's a Group 4.
And what does that mean?
Just by weight and capability. Usually it's a sizing thing, whereas the wingspan, if you will, on the Tradeshow is 45 feet 6 inches. It's but 22 feet on the Tiger Shark.
The Tradeshow is based on basically a motor glider.
It is a motor glider, very high lift wing. We've used that not as a motor glider, but used it for payload capacity and high altitude work.
So it has a long time to loiter.
It does. We are saying right now that the aircraft is probably a 24-hour 24-hour endurance at about 24,000 feet. And that varies widely with the fuel that you have on board.
When John was here earlier, he said that you were the organization that did the flight testing on the Taros. What was that flight testing regimen like?
We have not done that yet.
Okay.
We have not done the flight testing. That aircraft over there is done, ready to fly, but we're not going to test it in the air until this fall.
Okay.
Probably mid-September.
So you're still developing the parameters?
We're still developing some of the systems in it because we have the time right now.
Right. So when you do flight test it, what are the characteristics you're going to look for?
Where we're fairly lucky is it's not a new aircraft, it's a known quantity.
Right.
So we'll be flying it against what we know that it can do and make sure that it does that. That's first, and then go back and look for fuel flow, different, all the characteristics that you need to document as far as performance is concerned. We have little to no doubt that the aircraft's going to fly. That's not even in our concern, because John has produced a number of those aircraft, and they're very, very successful.
Something else that I noticed that's being worked on is a UAV based on the Subsonics jet.
Yes, sir.
And is that something that you're working on as
Very
well
much
with
so.
them?
Very much so.
What's the purpose for doing it with the jet engine and going to that configuration?
Some of the research that needs to be done by some universities and other groups need a higher speed aircraft. Could we sell it to the military? I suppose we could, but nobody's asked. So this is, right now it's a research and development platform. I think it'll be very successful.
And is there, from the looks of what I saw, it's not going to be the same basic subsonics. I mean, it'll have characteristics like the Subsonics jet, which a lot of people in the community that we deal with all the time are very familiar with, but it will be more loosely based on the Subsonics jet.
Well, it'll be based on a two-place, whereas the Subsonics as it is now is a single place.
Right.
All right, so right away it's considerably longer and a bit heavier. However, though, it would be immediately recognizable by anybody who knows any of the Sonics products.
Where do you see the UAV industry in that size category going? When you look down the road a couple of years or 5 years, and this is different than the quadcopters that so many people are buying and having and using in their homes. This is a full-size airplane.
Indeed it is.
What's the future for that category of UAV?
I think it actually is fairly bright. We are not in the quadcopter business. We feel as though there's sufficient people in that business.
It's a little saturated.
And we believe that we fill in that niche in that market, and we can fill it well. We have the capabilities as a company with just Navmar alone, and then teaming with Sonics Aerospace. I think we can fill that. To answer your question directly, what is the market? I think it'll remain research and development. As an example, working with people like GTRI or somebody like Georgia Tech Research Institute, somebody like that for air sampling, atmospheric research, weather, oceanic studies and things of that nature. I think that will remain, where a quadcopter cannot do that. As the Taros, we can send that out for like 800-900 miles and bring it back, where that's not in the quadcopter design suite.
Do you see that having use in like a search and rescue capability, because it does have long range and it can carry a lot of sensors?
Yes, we do. We've given that a lot of thought. And for emergency management, up coastlines and things of that nature, following a storm, right now they send out a quadcopter. It does a nice job, takes some pictures, but only can go so far, whereas we could do the whole, half of the East Coast in one flight.
There's also, I would imagine, because I know NASA does a lot with their Global Hawks in hurricane research and hurricane tracking and those things. The Sonics aircraft is not going to be that robust, I don't imagine, to be able to penetrate, but you might have some opportunities there.
No, we're not nearly looking for that type of aircraft. The however is we are arming it or equipping it with all-weather systems such as de-icing and all of those types of things to go into pretty rotten weather, for lack of a better phrase, and be able to be quite survivable. So to that extent, but to say like a Global Hawk to do
Yeah.
hurricane tracking or something, no, nothing like that.
So what is the advantage then of having an all-weather drone?
Well, right now, could you send a quadcopter up in icing conditions? Probably not.
Probably not. Well, you could. It wouldn't fly very long.
Exactly. Whereas this should be operate quite nicely.
And then, what kind of research do you see being done in that regard using an all-weather drone?
Well, anytime that you can get weather data where the weather's terrible, somebody's interested in that data. Especially things for icing. That's always a market for icing information.
What kind of systems have you developed specifically for not only the Taros but for your Tiger Shark aircraft as well?
Not a whole lot. Now keep in mind that the Tiger Shark, and to a greater extent the Taros, were built as platforms for you, the customer, to integrate whatever you want on it. So it's for lack of a better phrase, like a dump truck. You just load your stuff in here. Either you do it or we'll do it for you.
Okay.
But the basic design is to have as much space and as much power for you to use as necessary. And the Taros was built around that, where it has multiple access holes for multiple sensors and multiple radios and antennas and all kinds of acreage to put stuff, and it was done on purpose so that you could take that aircraft and integrate whatever you need. So we normally don't put that on there, though we can for sure.
Are you finding that customers are using commercial off-the-shelf technology to put into the aircraft and I know you haven't flown the Taros yet, but in the Tiger Shark, they're using COTS equipment that they can buy, place, and go?
Yes, but the answer to that is yes and yes. Yes, we can do that for COTS, but there are also some very sophisticated payloads, extremely sophisticated payloads. We've flown on it. And then yes, COTS stuff for sure, yeah, absolutely. And that's the beauty of the airplane, that it's not an aircraft that was designed around a sensor. The airplane was designed to carry as many sensors as you can find.
Well, it's very fascinating stuff, and it's. I have to tell you that I kind of came to this show expecting to see a lot more quadcopters and consumer drones, and I'm seeing more things like what it is that you're offering, and hybrid drones and things of that nature that were a part of the industry that I really didn't have a great deal of knowledge about. So I really appreciate the education that you and others have given me over the course of the past couple of days.
My pleasure.
Aero News Network's coverage of the Association for Unmanned Vehicle Systems International's Xponential 2017, live from Dallas, Texas, is brought to you in part by the following sponsors.
In collaboration with NASC, introducing Sonix Aerospace, bringing you the Taros Group 4 UAS, the redesigned Tiger Shark Block 4, and the Subsonics Twin Jet UAS, all derived from flight-proven manned systems, not concepts, real aircraft. More at sonixaerospace.com.
Let Patrick Neal & Associates provide the legal expertise needed to navigate the commercial UAS industry. Whether it be waivers, exemptions, operational plans, or other issues, we can provide the guidance you need to keep flying and building your successful UAS operation. www.droneattorneys.us